Hi everyone, Dr. Russ here to give a little demo of how to do the interpretation part of correlations. We're going to run through a problem. We're not going to do any math. We're just going to run through the parsing and the interpretation of the finding. So sharing my screen. So the problem we're working with today is called Education Seriousness and AI Usage. And the prompt is using alpha equals 0.05, test the hypothesis that there is a relationship between student seriousness about their educations and their use of AI internet to complete their assignments. Sample size n equals 45. And I've begun the process comparing students like those in our sample with students in general who have no relationship between the variables. So let's name the variables. I'm going to name the first variable listed as X. So X is student seriousness about education. And I'm going to name the Y variable use of AI or internet to complete assignments. Whoa, little typos here. I see that the direction isn't specified. It just says that there is a relationship. So I'm going to determine that this is a two-tailed test. And the research hypothesis is that rho is not equal to 0. I'm just going to do it in the coding way. Not equal to 0. And the null hypothesis is that rho is equal to 0. And so then the next step is to estimate the relationship. And I have done so. So let me put it up here so we have a little space. I'm going to just paste in the correlation. And so this is the correlation that we need to predict from. And you can see here that it goes in a negative direction, no severe outliers. So I'm going to predict a moderate relationship here. And I know our estimate, a moderate relationship is around negative 0.5. So that's my prediction. I'm going to look for something in that area. If I get something far different from that, I probably did something wrong. So the next thing to do is to find the critical value. So here is the tool that we're using at this time. See if I can drag it over there. Just a minute here. There we go. So here's our critical value tool. We scroll down to this critical value for R. I did type in the 43, but even though we have 0.05 significance, that's for a one-tailed test. So what we have to do when we have a two-tailed test is cut that in half. And half of 0.05 is 0.025. So I'm going to select the 0.025 here to find the cutoff point. Scrolling back down again, we discover that, let me see if I did that right, because let me just recheck that. Just going to run that one more time here. There we go. And it's 0.294. So let's go ahead and draw that on a distribution. So I'm going to just paste in a little distribution here so we can draw on it easily. And let's mark that 0.294 in each of the tails. So first off, in the upper tail, 0.294 is going to be way up here, even a little closer than I'm drawing it. R alpha equals negative 0.294. And another R alpha up here. R alpha equals 0.294. And now we have to shade both tails because we have a two-tailed test. So any scores that are falling lower than minus 0.3 or higher than, lower than minus 0.294 or higher than plus 0.294 are going to lead us to reject the null. Of course, as always, our fail region is in here, and we don't fail to reject the null if it's in there. So let's go ahead and finish out this problem. So I actually went ahead and did the calculation. Let me write this in here. R alpha equals negative 0.294. And you can see I actually went ahead and did the calculation. And I found our sample value of minus 0.4497. So now we can go ahead and plot that point. I can see here, here's the minus 0.2, minus 0.3, minus 0.4497 is going to be somewhere way out here. So our sample equals minus point, and I'll round that to 0.45. So in this case, we see that the sample score in red is in the shaded region. That's always what we're looking for. That allows us to reject the null hypothesis. So this gets crossed off, and we'll decide to reject HO. And the concluding statement is simple. There is a significant. Now, we only tested it at two tails, but we do find that it is a negative relationship. So to be clear, I'm going to just make sure and state this as negative so our readers know, between seriousness about education and AI usage for assignments. And we're going to put we'll put our degrees of freedom 43 equals 0.45. And the probability we're still going to state is less than 0.05 because even though we tested it, even though we selected 0.025, that's because we needed to know the amount in each tail, but we still tested at 0.05. So now we have to do these interpretations. It says complete only if the result was significant and HO was rejected. So that's what happened. And so here's the first one. It's given for us. Expected cause effect X causes Y. But our statement has to make sense. So let's label what is X. So go up here, X, student seriousness about education. So I'm going to write higher, serious, greater. Maybe I'll use the word greater. Greater seriousness about education causes less use of AI for assignment completion. And I think this researcher is talking about like cheating, just entering your prompt in AI and letting AI do the work. And next we have to see, is that plausible? Does it make sense that people who are more serious about their education would be less likely to just copy and paste an AI response as their submission? And I think this makes sense. I think, yes, this is plausible because students who want to learn know recognize that assignments help with learning. So students who don't want to learn that much, they might just use AI, but then they don't learn anything. So I think that's plausible. So next we have to see, but remember, that's not necessarily the way it works because it's just a correlation. There could be a reverse cause effect. We could have greater, let's reverse those two variables and put Y first, greater AI usage for assignments leads to less seriousness about education. I don't know. This one seems a little more like a stretch to me. I'm not sure exactly, but I think it is plausible. All right, yes, this is plausible. I think that students who, once you get into the habit of using AI, they might just think that learning like is easy and doesn't matter. Come to believe that learning is easy and be less serious about education. I think it's plausible. It could be in reverse. Once you start using AI, you get yourself into a trap. And now, can we think of a third variable, a question mark here that causes both X and Y? And first, let's make a statement. An unknown third variable could cause both higher seriousness about education and lower use of AI. And of course, the reverse could also be true. And what is such an unknown third variable that could both cause people to either use AI a lot and be less serious, or use AI just a little bit and be very serious? And maybe it could be like career orientation. For example, I'm thinking that someone who is really serious about getting a career as a psychologist would recognize that they need to learn a lot, and then they would use AI less. So I'm going to posit that a person who has that career orientation, I'm going to say, yes, this is plausible. A and then we just have to give one example of a third variable. An example of a third variable is career orientation, which might both cause students to be more serious about their education and use AI less because they're going to be in the field working. They have to know what they're doing. Oops, in the field working, so they have to know what they're doing. All right, so kind of a long statement there, but this is the idea. What I've seen in some work is people writing the statements using X and Y, but remember, that's not helping the reader. So when we write these statements in plausibility, we need to substitute in the variables. So the statement is just substituting in the variable for X causes Y, and then the plausibility is you thinking and deciding if you think it's really possible. That in general, the trend could go in that way. And these are tricky, but it's super good to get this practice. So I hope this little video helped you, and I look forward to seeing your work and how this comes out for you.